Hi guys, John the Quant here. This interview problem is exciting because it's simultaneously so easy and so difficult. The problem is pretty simple. It's if you have a well-shuffled deck of cards, how many cards do you have to draw before you get the first ace? What's the expected number of cards to draw before you see the first ace? And what we'll see is that if you think of this just intuitively, it's a super easy problem. But if you try to approach it analytically, it can get really difficult really, really fast. Let's jump on the iPad and have a look. Here we go. What is the expected number of cards to draw before you get the first ace? Now, there are a number of ways to solve this, and they typically range from hard to very hard. Luckily, there's also an easier way, and that is just to use our intuition, okay? So let's imagine a deck of cards. And we're going to have blue cards represent cards that are not aces, and red cards represent cards that are aces. So in a deck of cards, you have a whole bunch of cards, and they're stacked up like this. And every now and again, you have an ace. And I'm drawing a deck. I'm just putting a bunch of lines. I'm not even counting, frankly, because it doesn't matter. We're going to redo this in a little bit. But we've got this deck of cards, and it's stacked up like this, and there are 4 aces. That's the important thing right here. There are 4 aces. So if we think of this deck as a continuum, like this, then we know that there are 4 aces. And we know that this is a well-shuffled deck. So we would expect the aces to cut our deck into 5 equal sections. 1, 2, 3, 4, 5. 5 equal sections. So what's the size of each of those sections? So we have 52 cards total in the deck, minus the 4 aces, leaves us with 48 cards. We have 5 equal spots, so 48 divided by 5 is, we'll let it do it, 9.6. Hey, it even captured my handwriting pretty well. 9.6, and then, so we have 9.6 cards, then the ace, which leaves us 10.6. The 10.6 card is what we expect to be the ace. Now let's go over to the computer and simulate this in Python. This is really easy. We just need to import numpy as np. Then we're going to create a deck of cards. We're going to have 48 zeros, that represents everything that's not an ace, and 4 ones to represent the 4 aces. This is what it looks like. 48 zeros and 4 ones. Then we have a function here called draw until first ace. And we're going to index by 1. So the first card will be card number 1. Then we're going to go through the whole deck, and if we draw a 1, that means an ace, then we're just going to return the place that we're at. Otherwise, we're going to draw the next card. That's all this draw until first ace function does. And then we're going to simulate this 100,000 times. So we're initializing a list with nothing in it, and then 100,000 times we're going to shuffle the deck using np.random.shuffle, and then we're going to append the place that we got from our draw until first ace function. Once we've done that 100,000 times, we just get the mean of all those times and see that it is about 10.6, which we knew it would be. Well, that's how this problem is done. You can see that by approaching it intuitively, it became a super simple problem. Now, I challenge you to try solving that analytically because it is not easy. In general, my advice is to start thinking about the problem intuitively and see what you can figure out before you start getting this kind of advanced probability involved. A lot of these questions, they're not necessarily trick questions, but they're designed to see if you will think things through rather than just jumping straight into some kind of algorithm or equation. So let me know what you think in the comments. If you learned something from this video, please give me a like. And if you want to keep learning with me, go ahead and subscribe.